Oh. Yes. I don't think. This is the.
Okay, two more questions I wanted to go over. Okay, this one is, what's the hydrogen and chloride ion concentrations of the following acidic solution? Okay, now, remember, hydrochloric acid is a strong acid. That means there's no HCl around. It's only H's and Cl's, period. That's what the thing with strong acids. Okay, so I suggest you always write out the equation. So it's going to look like this. So whatever the concentration of this is, it's the same as the concentration of this and that. So we're going to base everything on HCl, even though it's not there. It's broken up into its pieces. So what's the molar mass for hydrogen chloride or hydrochloric acid? Okay, we have an H and a Cl. H is 101. Chloride is it 3545?
Yeah.
We're looking at 3646. Okay, so we're going 63.45 grams. And okay, that'll give us moles. And then those moles are going to be in 1834 liters of water. So this is all going to be over, let's see, let me rewrite this smaller. So this would be the concentration of the HCl. Okay, now, because it's a 1:1:1, that means the concentration of HCl is the same as the concentration of H and concentration of Cl. So this is equal to H plus. Remember, square brackets is a shorthand way of writing moles per liter. Okay, now this is all based on the fact that HCl is a strong acid. If this was a weak acid problem, we would have about 4 times the amount of calculations to do. And one is involving a quadratic equation, too. So strong acids are much simpler than weak acids. However, you will see that in 1A and 1B. I think weak acids are covered in 1B. Okay, any questions about this? Does this make sense? Okay, now the next problem is very germane to one of the take-home problems. So this one is really important to understand. Okay, so basically we've got a double replacement reaction between an acid and a base. So this is the acid. This is the base. And we're going to create water and the salt. Now, question is the amount of HCl and the amount of mole-wise, the moles of HCl and the moles of NaOH exactly equal? Most of the time it's not. There's an excess of one or the other. So we need to figure the moles of each and then compare them. Okay, so moles of HCl and is 1-to-1 with moles of sodium hydroxide. Now, as I mentioned yesterday, if we have a diprotic acid, that's going to change. We're using sulfuric acid, for example. We're using a really simple system of HCl, sodium chloride, so it's 1-to-1. Okay, so let's calculate moles of HCl. That's going to be, again, concentration times volume. So we've got, this is for HCl. We have okay, and then for sodium hydroxide, we've got volume times concentration, again giving us huh? No, tomorrow. Okay, so we've got a lot of excess sodium hydroxide. So how much sodium hydroxide is left over? Well, we're using 4 moles of it to neutralize the 4 moles of acid. So if we take so now we have 14.1 moles of excess sodium hydroxide. That is all in Okay, you see where I get the 585? We have liters of acid, liters of sodium hydroxide. Yeah,
We ever gonna take into account the water created? 4.0, 4.0.
that would be a good calculation to actually do and see how many liters that is. How much?
88.
88?
Is 4.
Okay, if we have. Okay, so creating water, let me finish this here and let me talk about that. That's a interesting. So the final concentration of sodium hydroxide is 18 moles per liter. Okay. Now, his question is, this reaction, neutralization reactions create water. So if we're creating water, that's going to add to the total volume. Normally we say we just ignore that, but let's see exactly. I divided, we have 14.1 moles of sodium hydroxide left over, and the total volume is 5.85 liters.
Yeah.
So I divided those and got 18. Oh, well, if you multiply them, you get 18. What did you get? Okay. Yeah, because 14 divided by 5 is not 18. Okay, all right. So this is why we're doing it live as opposed to the video. Okay, all right, so let's calculate the liters of water. Okay. All right, so if we calculate grams of water, we would stoichiometry problem, then grams of water is equal to liters of water. As long as it's water, it's 1 to 1. All right, so down here, we're going to go. So between HCl and sodium hydroxide, the only water we're producing is when it's a 1 to 1 between HCl and sodium hydroxide. So that's 4. Because we don't have enough HCl to go around. We can only produce 4 moles of water. So 4 moles times how many grams? For water, it's going to be 1802. Okay, we're looking at and again, a gram is equal to a milliliter of water. And then I'm going to divide that by 1,000 to get liters of water. So that's going to be what? So 0.072 liters of water. So that's going to add to the total volume if we were being very picky. If you were in 1A, that would be a really good question. And in your AP class, make sure you bring this up. really valid. Now, is 0.072 versus 5 liters significant? No, that's frequently why it's ignored. But it's a valid question though, and it really does add.
I thought it was 22 liters, 22.4 liters per.
Of gas. Yeah, and we're talking water. So if we're gonna do, see, there's liquid liters and gaseous liters. You don't have to say at all. Does that make sense?
Yeah, I see that a gram of water is a little.
Yeah, of liquid water. Yeah. Okay, so that's the practice test. Now those last two problems, particularly the last one, excluding the water calculation, is will probably take the most time. Okay, so any questions about tomorrow? You're gonna have 2 take-home problems to bring in, and you're gonna initial the back of your tests. I need to make sure you get 5 points for that. And you're gonna put it on the back of your take-home test after you staple it. Not on the back of your test, because then when you staple your take-home test, it's gonna cover it. Okay? All right, and then tomorrow we're starting our our titration lab. Now, we're gonna try doing lab 15 and 16 tomorrow and Thursday, rather than in 2 days. That means next week we'll be done with labs. And 2A, you do it in 1 day, and so I'm gonna try it this time. Okay, yeah.
We're doing. It's on. Then someone says.
Yeah. Right.
So do we still have lab then?
Yeah. Yeah, it's the gas lab. It's a good lab. You'll like it. Yeah. Oh, that's a good question. What about the pre-lab? You can combine them together. There's a lot of overlap, so it'll save you some writing. I'm glad you asked that. Okay, so combine your 2 labs into 1 pre-lab. And then also it's going to count 20 points, not 10 points. I'm going to give you credit for doing both labs. And I think we'll be okay. We're going to do 2 runs rather than 6 runs. We're going to do 2, well, we're going to do 4 runs instead of 6. 2 of them doing the base, 2 of doing the vitamin C. Okay, all right. So again, we're officially done with unit 3, including the review, the whole bit. So any last minute questions? And thanks for asking that. That was, I usually never do that calculation. So I'm glad you asked it. I'm sorry? Yeah, everyone in the lab scheduler, there's another lab, a gas lab, to be done at home. If you do that, I'll give you extra credit. Yes. And that was a spot decision I made 4 seconds ago. Made an option. It's a really good lab. I actually. Right, that's why I noted it, to do it home. Because we didn't have enough time to do the regular gas lab and the simulation. Yeah. Extra credit poster, everyone. They're due the last day of class. And Aaron, I wouldn't recommend you doing, you're gonna get an well, you probably need it. Okay, yeah, they're due Wednesday. And actually they're due Thursday. Thursday's the last day. Let me stop the video here. So our conversation will not be